All right, for this test, let's go through a couple of different things to know. First of all, you need to know revenue is PQ. You need to know cost is average cost times Q, and pay attention to what the question is asking. All right. Also, first derivative can give you critical values. It can give you intervals where F is increasing or decreasing according to the derivative being positive or negative. And it can also tell you relative max and mins. So when it's asking that question or those particular questions, you know first derivative. Second derivative, if it's asking you for concavity, that can tell you concavity. I don't know how to spell it. Concave up or down would be if second derivative is positive or negative on certain intervals. You still get critical values that may or may not be some of them the same. Don't worry about that. Just focus on what the question's asking. And then you have inflection points where your concavity changes. So depending on what the question is asking, you can find all of this information. So if I do the study guide by video, it may be broken up into 2 or 3 different videos. Find all the critical values of this function. So we're always thinking or talking about a parent function, but you have to find the information from the derivatives. To find the critical values for the first derivative, you have to find first derivative first, right? So first derivative would be 4x cubed minus 16x plus 0, because the derivative of a constant is 0. Secondly, set the first derivative equal to 0 and factor, because we have to solve for each of those x values to find the critical values. I can factor this by pulling out of 4x, and I'm left with x squared minus 4. Fully factor it, and we solve this one by using the 0 property. Set each x factor equal to 0, and you can solve for each x. In this particular case, we have x is 0, x is positive 2, x is negative 2. These are my critical values. They would be 0, 2, and negative 2. If I wanted to split that up into intervals, I would be testing negative infinity to negative 2, negative 2 to 2, and 2 to positive infinity for the increasing or decreasing. But the question was just to find critical values for first derivative. So find first derivative, set it equal to 0, factor, and solve for each x value. All right, so that's all it's asking. This second problem gives us another function. Let f of x equal 2x, you see it. Determine the intervals which f is increasing or decreasing. So first we have to find first derivative and set up our intervals from our critical values and do test values. So one additional step here. My first derivative would be 6x squared plus 6x minus 36. Got our first derivative. Now set it equal to 0 and factor. In this particular case, my GCF is a 6. We need x to the first power, not x squared. So we end up with setting x plus 3 equal to 0 and x minus 2 equal to 0. My critical values are negative 3 and 2. So now I need to separate my function, this curve right here, into intervals according to my critical values. Negative 3 to 2 and 2 to positive infinity. All right. First interval test would be negative 4. Negative 4 is in this interval. So whatever's true for negative 4 will be true for everything within this interval. Plug in negative 4 and just see what my sign is. Is it positive or negative? 6 is positive. Negative 4 plus 3 is negative. Negative 4 minus 2 is negative. My signs will be positive or first derivative. And let me write that like the first derivative test states. First derivative is positive. Therefore, my curve is increasing and this interval is going up. A test value, a good test value there would be 0. I love using 0. Positive, 0 plus 3 is positive. 0 minus 2 is negative. My first derivative is going to be less than 0. It's going to be negative. Therefore, my curve is decreasing from negative 3 to 2. And lastly, a good test value here would be positive 3. Whatever's true for 3 will be true for everything in that interval. Again, 6, 3 plus 3 is positive. 3 minus 2 is positive. My first derivative is positive because a positive times a positive times a positive is a positive. And we are increasing on that function again. So this particular section answers the question to A. What intervals is f increasing or decreasing? And according to my first derivative test, do I have max and min? And if I just kind of break it down into a visual, from negative infinity to negative 3, my function is increasing. I'm going up. From negative 3 to positive 2, my function's decreasing. And from 2 to positive infinity, I'm increasing again. So this is a perfect picture of a relative maxima when x is negative 3 and a minima when x is 2. So that would be good for that particular problem. That's the information that I'm looking for. All right, number 3, we worked this in class. The very first step that I did here was rewrite that according to my rules. I always rewrite. You don't have to, but I see it better because I'm visual. Plus 1/3 times x cubed minus x squared. I'm determining where the function is increasing or decreasing. First derivative again. My first derivative would be 1/4 times 4 is 1. So x cubed plus x squared minus 2x. That's my function. Set it equal to 0. And I factor out an x. And then I factor the trinomial. X and x, different signs. And 1 times 2, the larger is positive. So here, this critical value would be 0. Here, a negative 2 plus 2 is 0. And a positive 1 minus 1 is 0. So those are my critical values. Again, I'm going to separate that into some intervals. So negative infinity, negative 2 comes first. And negative 2 to 0. 0 to 1, and 1 to positive infinity. And we're using our first derivative, remember. A test value test value, test value, test value. Okay. So negative 3 would be negative if you plug it in here for x. Negative 3 plus 2 is negative, and negative 3 minus 1. Multiply those three together. Your first derivative will be negative, so your function f is going down, decreasing on that interval. Negative 1, positive, and a negative. Your first derivative is positive. Your function is increasing. You have a half. You got a positive and a negative. Again, your first derivative is decreasing since it's negative. And last, you've got a positive, and a positive. So we go back to increasing. Whoops. Increasing on that particular function. And what are we supposed to find out by that? We've answered part A. Determine points of relative extrema. They want to know, do I have max and mins? So my critical values, negative 2, 0, and 1. I'm decreasing from negative infinity to negative 2, increasing to 0, decreasing again to 1, and then I'm increasing again. So I have one maxima, a max when x is 0, and I have two minima when x is negative 2 and 1. This is asking to determine the points of relative max and min. You could find the exact values, the points themselves, by plugging x in, plug x into f of x. So when x is 0, let's plug it into f of x. You have 0 plus 0 minus 0. So at 0, 0, it looks like we have a max. The mins would be when x is negative 2 and when x is 1. We can plug that in. When x is negative 2, let me store that into my function. Then I can plug it into 1/4 x to the 4th power plus 1/3 x cubed minus x squared. And I get a crazy number, so let's put that as a fraction. And that would be negative 8/3. So negative 8/3. Let's put x, store x as 1. 1 store as x. And now I won't have to input that function again. Okay. And that is math 1 enter. That would be a negative 5/12. So that's kind of some ugly points, but you can see that we can determine the exact points by plugging our max and mins into our original function that we're analyzing. Number 4, let f of x equals 16x to the 5th. Determine where it's concave up and concave down. Go straight to second derivative. That would be 80x to the fourth minus 5. And we can, let's see, second derivatives.